the screen. All right, let me just get my
Perfect.
timer and then I will kick this off. All right, hi all. I'm Cale Kokenauer. I currently live and work in Colorado Springs, and this is aWherePy, which is the Python package I created to work with the Aware API. First off, a little bit about project roadmap. I'm going to be covering the first couple aspects here, whether it's the package itself and the functions. And you'll actually see in the next presentation, Drew's going to cover how he was able to actually incorporate some of what I did into his project, which is pretty cool. So first off, what is Aware? What is the Aware API, and why do you care about it? So Aware is a benefit corporation here in Colorado that has APIs for global weather and agricultural data, or agronomics data. And their current instantiation and tools they use to access, work, analyze, visualize this data is all in the R programming language. So specifically what I was doing here, I created a Python-specific solution, Python only, Python package to do the same thing, access, visualize, work with, analyze the data, to create a vehicle for the Python community to bring this data to the kind of the Python scientific community. And beyond that, aWherePy itself, it's a GitHub repository with code for functionality, code for testing, a couple of continuous integration applications to help automate the software builds, and then the online documentation to keep it as a standalone. The way that the modules are actually structured, there's a main module to handle authenticating to the API and 7 modules to handle the various types of data within the API. Today, I'm specifically going to focus on just the weather API or the weather module and the grids module to give you a little flavor of what the capabilities are. So first off, all data within the Aware API or APIs comes in a 9x9 kilometer grid cell. And so any lat long combination that you input into the same cell returns the same data. So in order to avoid duplicative data, the question is how do you enforce a single point per cell? So the functionality I have here takes any kind of study area boundary, whether it's a shapefile, and buffers it a little bit and creates this Aware size grid from it, and then allows you to extract the grid cell centers, centroids, which you pass to the API to actually get the agricultural and the weather data. So it enforces that one single point per grid cell. The other big question is, how do I integrate other GIS or geospatial and remote sensing data with this Aware data so I can use Aware and non-Aware data in the same workflow? So the functionality here rasterizes any finer grain resolution data up to the 9x9 kilometer grid cell. This specific example shows the world population data from the state of Vermont, which is natively 100 meters by 100 meters, and it aggregates it by sum up to the 9x9 kilometer grid showing the population. There's a bunch of other aggregation statistics you can use, and there are certain considerations you might want to think about for other data sets. To use the Sorry about that. Can you see me?
Yes.
Yeah, sorry, my Zoom quit on me. I don't know what happened there. Let me.
Fast comeback.
I know, that was.
So can you see the same slide I was on?
Yes.
Yes.
Except it's in presenter mode.
Excellent. I don't know what happened there. Sorry about that.
No worries. This is, I'm sure everyone can relate, right? This is our world now. A world of Zoom.
I'm glad it came back instantly, which I've a little surprising, but let me. All right, is it back?
Yes.
All right, so what I was saying there was you can use Aware and non-Aware data at the same resolution. Next example here is showing precipitation data. This is specifically the weather module for a single grid cell, single lat long in Rocky Mountain National Park. So on the left, you're seeing left subplot, y-axis is precipitation for a specific day, and on the x-axis is the date, showing the total precipitation. So in green, the line plot shows the total precipitation per day for this 10-day period. The line plot in purple shows the historical average going back the last 10 years. And then the subplot on the right, same axes, shows the difference between the two, showing which ones are above the mean, which ones are below the mean. And this is not really any type of analysis, but this is the kind of the baseline data you can get back and what you can do with the Python package I created. And there's a lot of other weather data, such as weather forecast data or agronomics or agricultural data you can use as well and do the same thing. Just circling back to roadmap, I covered the first couple. You'll hear about from Drew's presentation about how he was able to bring some of this into his workflow, which is pretty cool. I also have a side kind of concurrent roadmap. I have this package is now live 0.10 version 0.10 is live on PyPy, which is the Python package index. It's also available on CondaForge, and I will be submitting it to PyOpenSci shortly once I can refine some things and make sure all my ducks are in a row. And then I'll leave you here with a few links, link to my GitHub, link to the CondaForge channel where the Python package is, link to PyPy, and I do want to thank David and Lauren at aWhere. It's been really great working with them. I want to thank Leah and Jenny for the certificate program, because there's no way I would have been even involved in this, if I hadn't been a part of the program. And I do want to thank you for your attention, and I'll stop there. Thank you.